Hi guys, welcome back to another video. In this video I'm going to be making sodium nitrate from nitric acid, which is going to be used to make red fuming nitric acid. Now there are two types of nitric acid. There's azeotropic nitric acid, which is 68%, and then there's fuming, which is higher than that, normally around 90-80% nitric acid. And you cannot be wearing gloves working with the fuming nitric acid, but you can be wearing gloves working with concentrations less than 68%. So we'll be working with sulfuric acid and all different chemicals. So gloves, glass, eye protection, lab coat is all necessary during this entire procedure. And especially when working with fuming nitric acid, do not be wearing gloves when distilling off the fuming nitric acid, as it will set your gloves on fire, and it's just more dangerous to be wearing gloves. So yeah, it is also in the name fuming. It fumes, so be working in a well ventilated area. Same with methanol, it's quite volatile, so be working with that in a ventilated area. Same with just normal 50-odd% nitric acid. It also vapors, well ventilated area, fume hood, anyway. I did the maths here to make the sodium nitrate. Basically, I said I wanted 450 grams of sodium nitrate. I know that's a lot. I did get around 5 liters of nitric acid for free, so that is why I decided to do this experiment. And I did this more for the procedure, which is quite, it's got a lot of practical learning into it. And I did the maths. The maths did work out at the end. So let me just run you through this. Nitric acid, sodium carbonate makes sodium nitrate, and water and CO2. I said I wanted 450 grams of sodium nitrate, which is this many moles, and I'll need. I said I need 333 grams of nitric acid, which I've worked that out into milliliters because my scale's pretty bad. And yeah, and then I'll be using that nitrate salt with sulfuric acid to get nitric acid, which I've worked out get 333.52 grams of nitric acid, which, as you see, this is the same number as I started with, which is correct. That's how it should be, the conservation of mass, so you can't gain any mass or lose mass. So this worked out. The only problem is during the procedure it didn't really work out, as you'll hear later. Something was off. I'm pretty sure this is correct, but if someone finds a mistake, please let me know. Overall, I didn't have enough sodium carbonate to react with the nitric acid, so either my scale was very far off, which I don't think, because I actually added quite a lot of sodium carbonate to it to try and neutralize it, and that didn't happen. Or maybe my sodium carbonate was actually a bit wet. It's pretty dry, but maybe it was some sort of hydrate. I'm not sure, but maybe that's messed with the scale. But even then, it shouldn't have been so much extra to try and neutralize it, which at the end I still didn't neutralize it. But nonetheless, that's the procedure. This is going to be part 1 because it's quite a long video. Sorry about that. I can't make it any shorter. Maybe if I can't really. But yeah, see you in the next clip, which is going to be starting the process, measuring out the chemicals and everything. There is a part where I used a Dimmeth condenser with the reaction of sodium carbonate and nitric acid, and I thought it was exothermic, but in reality it actually was pretty tame. Like, the thermometer barely went up, and the whole Dimmeth condenser addition to try and recapture any nitric acid that didn't react or anything like that was not needed. So you can just do this reaction in a beaker if you want, just slowly, because it foams a lot. So yeah. Alright, I've measured out 280 grams of sodium carbonate, and yeah, so next is the nitric acid. This is quite a hefty amount of sodium carbonate, not gonna lie. I need 500 odd milliliters, so it's definitely gonna need constant stirring. Okay, so I will be measuring 561. I added a little bit of excess to make sure all the sodium carbonate reacts to sodium nitrate. So I got quite a hefty amount of nitric acid here. I'll measure using my 250 milliliter graduate cylinder. It's the biggest one I have, so I'll just have to do it in portions. I'll pour all this into here and then throw this into the graduated cylinder, and then when it reaches 250, I'll throw it into this 500 milliliter aluminium flask. So yeah, so there's a bit of glassware needed. You don't really need this beaker, but you need to. I can't pour this into here very accurately and steadily, if that's a word. So yeah, so let me do. Alright, so I've measured out 260 milliliters of nitric acid, which is 59.5% according to the bottle. Hopefully that is correct. Like, yeah. Yeah, so this is quite a bit to mix together, so I might have to do them in 2 separate batches, because I think this is more of like a 2 liter situation, because it's like 500, this is, looks like fits half the beaker, so definitely won't be able to put this in a 1 liter round bottom flask, so I might have to do it in 2 batches, half this and half that, but that's a bit difficult because I'll need to work that out, so I'll have to do that, yeah. And yeah, so that's what I'll get to next. Hello again. So now I've got the setup a bit ready. I've got the round bottom flask attached to a pressure equalizing funnel. Now what's going to happen is I'm going to take this, so I'll half the batch, so there's the other half, here's this half, well not half, but like stoichiometrically halved it. I said I want to use 140 grams, how much nitric acid, it's in the book, forgot. Yeah, so I'm going to take this, crush it down in the mortar and pestle, and pour it through here to get it into the flask. And then I'll attach the Dimmoth condenser, water supply, and pour the nitric acid into there, and slowly start adding it. Now this is going to produce a lot of CO2 and a lot of heat. Will be an ice bath here. The CO2 run out of the Dimmoth condenser since the top will be open, because you don't want to pressurize the closed system. That is, something's going to pop. Yeah, so let me do that. Alright, all of the sodium carbonate is now in the flask. What I'm going to do is I think I'm going to add 70 milliliters of water, just so that when I add the nitric acid it doesn't react immediately, and it's just a lot calmer if I add a little bit of water. It's not going to dissolve all of it, but it will help the reaction just run a bit smoother. There's 70 milliliters of water. As you can see, sodium carbonate is very soluble in water. Alright, so the beautiful Dimmoth condenser is added. Look at this stunning thing. Absolutely stunning. And the nitric acid is added to the dropping funnel. It's 250 milliliters. I don't want to push it to the limit there. A little bit spilled, it ran through the side, which is good practice to move the arm opposite where you're pouring. But that's okay, it was only a little bit. So yeah, I'll turn on the water and then I'll throw an ice bath in here and I'll start adding the nitric acid. Let's watch the water go up. Into the bucket. Ah, so nice. I will now begin the addition. Be a lot of CO2 vapor coming off. I'm going to slow the drip rate. Okay, that's a pretty good drip rate, and I'll leave it like that. You can see a bit is condensing on the condenser. Quite nice, and yeah, I'll come back when this is all done. Alright, so I've reacted all the nitric acid with the sodium carbonate. However, I've come across a problem where I I measured out actually only 510 milliliters of nitric acid instead of 560. But the worrying part is that there's still a lot of nitric acid actually in here. Like if I take a little bit of this sodium carbonate here, it's just washing powder, it's not going to hurt my hand, and throw it in. As you can see, it's still reacting. So now, this kind of messes up my entire calculations because clearly something's not right, especially when I use less nitric acid. And I'm pretty sure my calculations are correct. I'm sure, like, I might get a comment saying that it's wrong, which will be fine because then I can see my mistake, but it worked out at the end. Like, I got the same amount of nitric acid that I started with and I ended with because of the law of conservation of mass. So, yeah. So what I'm going to try and do, I think this is just what I have to do because I really don't want leftover nitric acid. So I'm going to throw as much as sodium carbonate in there until it stops reacting. I really don't want to do that, but there seems like a lot of nitric acid in there. And then I'll add a little bit of water until this at the bottom here is all sodium nitrate that's not dissolved. After all the sodium carbonate, I'll add some water to get that all dissolved, and then I'm going to filter the solution. As you can see, it's not very clean. So yeah, I guess that's what I have to do. Alright, so I've stopped adding the sodium carbonate. It's still reacting. I'm just going to leave it if there's a little bit of nitric acid left. I'll hopefully get my 400 odd grams of sodium nitrate. I really hope. I hooked it up to the stirring bar, and I'm going to add water until the sodium nitrate there is dissolved. The best stirrer, but alright, most of it's dissolved. I'll now filter it through some coffee filter papers. You see I got the funnel here like that, so yeah. And yeah, that's what I should do now. I'm gonna need 2 hands for this, and hopefully I don't spill. Alright, so all the liquid has now been filtered. As you can see, it's nice and clear. Now, it's getting late. I gotta go to bed. There's all the dirty glassware. I'll clean that up in the morning. Yeah, that's all the grime that came off. Well, grime, I don't think is the right word, but dirt. And now I have to boil all that down, and I am scared because that is a lot of liquid. Holy moly. I am not looking forward to trying to get rid of that. I have to think about how to do it most efficiently. Maybe multiple beakers, because boiling this whole thing at once is just not that efficient. I have 2 1-liter beakers, so I'll maybe half it or try something. I don't know. Hello, welcome back. It's the next afternoon actually, and I've decided to distill the leftover liquid because knowing that there's nitric acid in it, I don't really want to boil it in the air, and I would like to get some of it back, so I'm going to decide to distill it. It may take me forever, but I think it'll be cool to see how much nitric acid or dilute nitric acid I shall get. The only thing is now is like, I'm going to boil this down, and then I'm going to add the rest, which is over here. See, it's not too much left, but then when it cools down, it's going to, all the sodium nitrate's going to crash out of solution, which is going to make like almost a solid. So I think it'll be fine, because if I add the rest of the solution, it should dissolve the rest of the sodium nitrate, and as I heat it up, the boiling and agitation should also dissolve it. Yeah, and then when it gets to quite a saturated solution, then I will pour it out of the flask, rinse the flask with some water, and then let it evaporate in the air, or boil it. Well, I'm going to boil it off, because I can't really have it clumped up in the flask here, otherwise it's going to be impossible to get out. But yeah, so this is the setup, normal simple distillation. I don't have an O-ring for the thermometer adapter, so I just got this cap that fits perfectly over it. I'm quite happy about it. I finally got some K-clips from the last order. Hopefully these K-clips are fine, because it is kind of like, I think it's dilute nitric acid, so it should be fine. Normal condenser, another K-clip here, and a 1 liter round bottom flask. This is also a new addition. Now I got a 1 neck 1 liter, it's quite nice. Yeah, I also got a huge bucket of water here, because the more water, it's going to take a lot of energy to heat up the water, so I can actually leave this run and I can go do some chores. Even though it's like an open flame, it should be fine. I've done it before. It's like, yeah, it's nothing really else can happen aside from maybe foaming or something. But yeah, that's why I put a lot of water. I'm gonna throw it with ice when it starts distilling, so it can start off really cold. And yeah, so I'll come back when most of this is distilled over. Right, the solution has come to a boil. Not gonna lie, this flask is a bit full, but it is okay. As you can see, it's managing it. This is really cool, because I added a glass like pipe almost. It was like left over from this thing here, like two. And since it's a round bottom flask, the two ends of the pipe will touch two places. That means there'll be two places for like boiling to happen. So it makes it really nice and smooth. So I thought that was pretty cool. As you can see, the condenser is quite working here. There's a lot of liquid here. As you can see here, it's quite dripping quite often. I'll add some cold water now. It is condensing over here. I love science, it's so cool. But yeah, you can see there's a lot of liquid there. This might go reasonably okay, like in speed wise, but yeah, don't worry about this situation. It's just like I need to go do stuff, and for the only way something can actually burn is if this thing tips over, and if it tips over, this water pot will tip over, so it'll make water everywhere. Yeah, it's just an idea really. But yeah, this magnet is really strong, and it's hold on to the pot, so it'll be perfectly fine. What could possibly go wrong, right? But yeah, I will come back when more of this is distilled. Alright, so quite a bit of the liquid has evaporated off. You can see it's quite a bit in there. So now I've stopped the heating. I'm going to wait for it to stop boiling, and then it'll cool down a little bit further, and then I'm going to add the rest of the sodium nitrate solution, just so I can get everything and then in one thing, and just when it's going to be the end. I'm really not sure exactly how much liquid it's going to evaporate off until it all crashes out of solution. Alright, so I added the rest of the sodium nitrate into the flask. As you can see, I used a long stem funnel so that the stem misses the still head, so that no sodium nitrate contaminant goes around there, and instead goes straight into the flask. I let it cool down a bit, just so that there's not much of a thermal shock. The flask could probably definitely handle it, but I just want to be safe, because if this whole thing just cracks or something, it'll be scary. But yeah, so now I'm just going to continue heating it and bring it to a boil again, and hopefully collect the rest. You can see it's actually quite a bit of liquid in here. It's a 1 liter flask, so when it fills up to around that much, it's quite a decent amount of liquid. Or should I say nitric acid. And when I took the stopper off, there was a lot of fumes, as there should be, as nitric acid fumes a lot. So it's obviously very important that when you moving more solution into the flask, is that you wear gloves so that the nitric acid fumes doesn't really hurt your skin. But it's mostly okay, you can just wash it off. But yeah, I'll bring this back to a boil, and hopefully it doesn't take too long, because heating up all this liquid normally takes around half an hour to 20 minutes. Alright, so I turned off the heating now. As you can see, the solution has gotten murky. There's all the stuff received, dilute nitric acid. It's a lot. I'm really glad I distilled it. And I was a little cookie mark to see where it was at certain points. You can also see the solution's murky, as I think previously mentioned, which means if I leave it for a bit longer, unsupervised, everything's going to crash out and it might become a solid lump of sodium nitrate, and then this will heat up, and I don't want that, so I turned it off now. And I'll come back sometime, maybe tomorrow, or maybe tomorrow morning. Nah, not tomorrow morning. But yeah, and I'll check it out and see how it's doing. As you can see, the heating's off, but all the sand in here is still retaining heat, so it's passing it over, and this is going to boil for a bit longer. There's so much liquid in there. Alright, it's the next morning. I've now put it in the freezer. Probably going to put it there for like an hour, and to get most of the crystals out there. To do it like that. And yeah, because it has not moved from when it was hot to when it was cold. Like through the night, like there wasn't much any crystals. You see I put a marker, the dot is the marked point, so like it hasn't moved at all. So I'm gonna put it in the cold and see if I can get any more out, and then I'll pour that water off separately, mark it, and then boil it off to see how much sodium nitrate's in. Alright, so I'm back. Currently I got methanol in the freezer cooling down, so I can clean this. I'll just rinse it with methanol. Normally methanol and nitric acid is not a good mixture to do, but it will be cold methanol, so it should be fine. And right now this is the leftover solution that was in the Erlenmeyer flask, and I'm just gonna neutralize it with baking soda here. I hope this is enough, and you can see I got it on stirring, so yeah. Alright, so what I've done is I put a little bit of my sodium nitrate of crystals into this small funnel here, and I added a little bit of cotton wool at the bottom, and I rinsed it with methanol to see what would happen. So right now this is acidic, and I checked the pH after a few washings. It took about that much methanol to clean this a little bit, and it became to be my litmus paper disappeared. Well, it was blue, but yeah, it's kind of stayed blue, so that tells me it's pretty neutral. So what I'll do, I'll just do that, rinse the whole thing with methanol and then let it dry, which is really nice because when you rinse something with methanol, it makes it dry a lot faster, because like methanol is also like very volatile. Same thing with alcohol. Like some people would, maybe me at some point, but you can take some pure alcohol, and if you need glassware immediately and you can't wait for the water to dry and you don't really want water in your system, you just rinse it with ethanol, and then it should dry really quickly, because so let me set up a bigger process and do that, because it seems like it just seems like it's working. So yeah, alright, this is the bigger setup. Still have all that to filter or to clean. And I'm gonna put it, I thought about putting it in this beaker, but then I thought this is probably going to be way better for drying, because the stainless, or stainless steel, but like the metal would reflect the heat, so it will keep it warm, unlike the glass where the heat could just pass through with sunlight, in terms of sunlight. Yeah, so yeah, so now I'm just gonna move this over into here and let it dry out somehow in the air and the sun. And yeah, hopefully I get around the amount that I predicted, but there's so many things that went different. Like I had so much leftover nitric acid. This is dilute, but there was still obviously a concentrated amount, because when I react the sodium carbonate with nitric acid, I form water. Well, I don't make it, but I make water, yeah, so it'll immediately dilute the nitric acid. So yeah, but yeah, so now we'll do that, and I'll come back when I've done all of it. Unfortunately, there's not a lot of clips of the chemistry. It's just me updating, but I only have 2 hands, and I don't have something to hold the camera. And normally I would put my phone in this mortar and pestle to hold it, but you see how high the system is, so that's not gonna work if I put it here. Well, it's not even there. It will actually have to be here. But yeah. Right, welcome back. So right now all the sodium nitrate is dried, and I've weighed it to be 280 grams, which is okay. It's quite a bit, it's quite a lot of sodium nitrate. Just that I wanted to get 450 grams, but it's okay because I have a lot of unreacted nitric acid, so I recovered that from the distillation. Thank that I've actually like just recovered it, otherwise it would be a big loss instead of boiling it out, you know. So yeah, so I've recovered that, and I still have this solution that was off like the top layer of crystal, so that was like over here that I poured out to lower the volume, so that had some sodium nitrate in it. I can boil it down, but I'm not sure how much I'm gonna cover it. I'm really too lazy for that now. But I'm decently satisfied with 280 grams. Now I'm gonna have to do some stoichiometry to see how much sulfuric acid I'll need and how much nitric acid I'll make. I'm thinking about keeping some sodium nitrate, but I'm also not, you know, because the purpose was to make it for the nitric acid. But yeah, I'm quite happy with this amount. Like, it's quite a lot, and the crystals are very nice and clean, and it's dry now. But it would be weigh a little bit less than 280 because it's probably, I'm not sure what type of hydrate it will form, but it is hygroscopic, so it does have like molecules of water attached to it. So yeah, preferably if you're making like fuming nitric acid, you would want it to be like completely dry. So I'll dry this in an oven, but I don't have an oven, so the sun is my best bet. Nor do I have like a steel container for the Bunsen burner, otherwise I could heat it up in there, but yeah. Anyway, so this is definitely gonna, I'm definitely gonna stop here. This is gonna be part 1, and then part 2 will be the making the nitric acid.